right, good morning, everybody. How you doing today? Good. Excellent, excellent. My name is Brittany, and today I am going to be your science interpreter. Everyone say, hey, Brittany. Hey, guys. And, of course, it'd be rude if I didn't get your name. So on the count of three, I'd like everyone to yell their name for me. 1, 2, 3. So nice to meet everybody. I'm so glad you guys are here today. Science is a lot more fun to do together. So today, if you guys have any questions, feel free to raise your hand or stick around after the show where I will try to answer any vaguely related science questions. Now, today, we are going to be talking all about science. I was going to say stuff. Stuff. Is stuff a very scientific word? No, it's not super scientific. I wouldn't write it down on any science test that you had, but what word can we use instead of stuff that's a little more scientific? Wait, this guy raised his hand right here. Not quite. Tools, I like that word. It's a sciencey word, but not what I'm looking for. Materials, you're getting even warmer. It starts with the letter M, and it can mean anything in the whole entire world. Not mass, but this has mass. Matter. Can we say that together? Matter. So today, we're going to talk about chemistry. And chemistry is all about matter, how it acts, how it behaves, and how it can change. Now, have you guys heard the word combustion before? Yeah. You have. What do you think of when you hear the word combustion? Something blowing up. We're going to be blowing some things up here. Is that okay? Yeah. Are you sure? Yeah. Okay, all right. I'll give you warnings when anything is about to happen so that we're not too spooked here. What else do we think of when we hear the word combustion? Setting things on fire. We're going to be doing that too. Is that okay? Yeah. Okay, excellent. So I've got a combustion reaction for us to check out here. Now, like we said, we're going to be talking all about different types of matter. And I just so happen to have one of my favorite pieces of matter to experiment with. It is, drumroll please, a piece of aluminum foil. Pretty cool, right? Now, how can I change this piece of aluminum foil in my hand right now? What can I do to change it? I can ball it up. Do I still have aluminum? Yeah. What else can I do? Blow it up? Well, let's wait a little bit for that. What else can I do with it? Right here with my hands. Yeah. Eat it? Tastes like metal. I don't want to do that. But is it still aluminum even if I put it in my mouth? Yeah. What else can I do? What? All right, you guys want me to set this on fire? All right, let's see what would happen if we tried to burn this, okay? So now, I don't know about you guys, but when I'm heating up leftovers, I always wrap it in aluminum foil, all right? And I put it in the oven. And let's see what happens if we just put a little bit of a flame underneath of my aluminum foil. Now, we don't see much happening here. All right, aluminum is not a great source of fuel. It warms things up that's inside of it, but the great thing about aluminum is you can put it in an oven. So, all right, nothing's going to happen to this if I try to light it. So, what else can I do to this piece of aluminum to change it? Yeah?
Can you blow it up?
Blow it up? Well, we just tried to light it on fire. Nothing happened. How about if I rip it? If I rip it, do I still have aluminum? Yes. What if I rip it again? Do I still have aluminum? Okay, what if I rip it down to the teeniest, tiniest unit in science? So microscopic you can't even see it. Does anyone know what that teeny tiny unit is called in science? The smallest that we could possibly get?
A particle?
Not a particle is a general word for this. It starts with the letter A. Atom, exactly. If I rip this down to an atom, would I have an atom of aluminum? Yeah, absolutely. Aluminum is one of the elements on the table of elements. It's a type of atom. And that's why this is so special. It's only made of one kind of atom. It's made of aluminum. Exactly. Okay. So this, I can tell you guys aren't impressed, but don't worry. I have something a little more complex for us. Another drum roll, please. My second favorite thing to experiment is paper. Okay, now, besides for burning it, we're going to save that for last. What can I do with this piece of paper to change it? To change this piece of matter, what should I do? Rip it. Do I still have paper? Yes, absolutely. Now I have paper in two hands. What if I rip it down to that teeniest, tiniest unit, an atom? Do I have an atom of paper? Is paper an element? No. Paper is actually made up of a few different kinds of elements, so this is a lot more complex than aluminum is. It's made of carbon, oxygen, and probably a little bit of, I would guess, hydrogen maybe? So we've got this paper right here. Now, should we try to burn it? Yes. Let's see if we can create a reaction with my paper here, okay? Now, I know that you all know what fire looks like, but today we're all going to be scientists, so I want you to observe what I'm about to do. I want you to be able to give me some observations about how do you know that this is burning right now, okay? So what are some of the hints that your senses can give you to tell you that this is in fact burning? Well, besides from the fact that it's burning, how do you know that? It's crumpling up and turning into this gray stuff. What do we call that gray stuff? Ash. All right, so we're seeing ash, we're seeing a bright light, a flame. What else do we see? Smoke. We're seeing smoke go up. Can anyone smell anything? Yeah. I can kind of smell it up here. So let me ask you something. This whole thing just crumpled up. If I take the smell, the smoke, the ash, and all of that flame, and I put it back together, can I make a piece of paper again? No. No. So this is an example of a combustion reaction. A combustion reaction is a change that we make that we cannot turn back. Once we light that piece of paper on fire, we're not getting that piece of paper back. So it's an irreversible chemical change. What we were doing over here, ripping up this piece of aluminum, we were just making physical changes. Changes to how it looks, but we didn't change the atoms at all. All right, so now using this experiment, even though it's very simple, let's figure out the 3 different ingredients for combustion, okay? So think about what we just did, burning the paper. What was one of the ingredients that we used? Yeah. We used fire, excellent. So in every single combustion reaction, we're going to need a form of heat. And we're going to talk about it later. It doesn't always have to be fire. It can be a few different things. All right, so we have heat. That was my flame. What else did I use in that reaction? Well, smoke was a product, right? You're not wrong. Smoke was a product of that combustion reaction. I used the paper. And in this case, the paper acted as our fuel. Exactly. So our fuel is what we are setting on fire. This is what feeds the flame. So now we've got 2 out of 3 in our combustion triangle. We've got one more ingredient. This one's a little bit tricky, okay? What else do I need to create a flame or combustion? Yeah.
Air.
Air. Specifically, what in the air? Oxygen. Excellent. We need, last but not least, a oxidizer, okay? And where did I get the oxygen in the air?